Welcome to Module 4 of this series on chi-square, ANOVA, and selecting the best technique to employ. In the last module, you learned about validity and reliability, as well as statistical techniques such as correlations and t-tests, which are two common statistical tools that are used in research and in some job-related evaluations. Now in this lesson, I will introduce you to two more tools, and that is the chi-square and the ANOVA. And after you learn about these particular statistical techniques, you'll then learn how to select the best tool for your research purposes. Now you can see in the middle of page 1 of your workbook the objectives for this workshop. You'll see that we're going to define a chi-square, we're going to interpret a chi-square output sheet, and we're also going to determine how a chi-square's use is useful within a research study. We're going to follow the same process for an ANOVA. And then finally, we're going to select the best technique to employ given the conditions of a research study. So you can see the outline that we will progress to. So let's turn to page 2. Now we need to review some background information from past modules before we proceed in this one. It's important that you recall what the scales of measurement were that we introduced you to in Module 1's target lesson. So let's review and go ahead and take a few minutes to shut the video off so that you can name and define the 4 scales of measurement. And then after you have your answers down, then you could come back and do the debrief. If you find that you're having difficulty recalling the 4 scales of measurement and how to define them, then go ahead and rewatch the video. I have the link on page 2 for you to review again. It's the same video that you reviewed in Module 1, but it'll help you to recall the scales, and then you could come back for the debrief. So, as a review for the scales of measurement, you will probably recall that there was nominal, there was ordinal, there was interval, and there were ratio scales. Nominal scales deal with categorical data. So these are items that you name. So male and female, we might name male 1 and female 2. We might have year of class within a university. So freshmen could be 1, sophomores are 2, juniors are 3, seniors are 4. We could even change the numbering system because the numbers don't really mean anything. All those numbers are doing are they're acting as symbols or naming some type of word or category. Then we have ordinal data. Here we're rank ordering items. So there is some sense of order to the layout of the items that we're dealing with. The third scale of measurement is interval data. Here we have equal intervals without an absolute 0. So we know that if there's 4 different positions, that the space between each position is of equal intervals. In contrast, ratio data has equal intervals with an absolute 0. So a thermometer would have an absolute 0. Salaries, if we're dealing with salaries, then we're dealing with an absolute 0. So those are the scales of measurement. So now we're on page 3 of the workbook, and we're going to get into the 2 techniques that are part of our main lesson, starting with the chi-square. Now, unlike correlations and t-tests that you learned in Module 2 that used interval and ratio data, here the chi-square technique often employs categorical data, so that's nominal data. So for example, gender consists of 2 categories, or may consist of 2 categories, male and female. Year in school may consist of freshman, sophomore, junior, senior, and graduate students, as we had mentioned earlier. So these are categories or nominal data, and this is where the chi-square can be useful in analyzing nominal data. Now the fundamental purpose of a chi-square is to measure the fit between observed and expected data. So to get a better understanding of a chi-square, I want you to watch this video. Now don't get too caught up in the fact that he's hand calculating a chi-square, because you won't be doing that. But just watch what he's observing in terms of the variables that he's using and the examples and his hypothesis that he's testing. So go ahead and shut this video off and go to this URL to watch the video and then come back to this lesson. So you have an understanding of the chi-square. We're going to go into a little more detail about reading an output sheet to help you better conceptualize the chi-square, as well as the output sheet will also help you when it comes time to understanding where the researchers, when they cite information within their results, where that's coming from. So if you turn to page 4 of the workbook, if you recall in the last video that you watched, the presenter used examples of gender and its relationship to littering. Thus, there were two categories. There was gender and littering. Both categories are nominal data. That's why the chi-square was used. If we actually entered similar data into SPSS, and again, SPSS, for just in case someone doesn't know what SPSS is, it's a statistical software package. So you would actually have to run, when you collect data, you have to enter it into some software which will actually run the results. Unlike the presenter who is hand calculating, you don't need to do that. SPSS will do that all for you. If you look on page 4, I ran a similar study using gender and behavior, that is, those that littered and those who deposited the trash in the trash can. Now, I did not use as many subjects as he used. I only used 10 men and 10 women. And you can see in this first box here with the number 20 shows how many subjects were used. If you look at the second box, you can see we have the gender, and it's broken down by count and expected. And then you got the littered or who deposited in the trash. So the count is the observed and the expected is what we were expecting to get. So we expected 4, but we actually got 6. We expected 6, but we actually got 4. We expected 4, but actually got 2. We expected 6 and actually got 8. So that gives you the observed and the expected. But the big thing, just like any statistical output that you might read, you're looking to see, was this test, was this chi-square statistically significant? And so we go down here and we look at the p-value. Now remember, our whole goal is to get a p-value that's less than 0.05. And we look here, and 0.068 is actually greater than 0.05. And so this chi-square is not statistically significant. So we did not prove anything within our study. There are no differences between men and women as to whether they deposit trash or litter more frequently. So now let's look at the chi-square in an actual study. You've gained conceptual understanding of what a chi-square is, and you have a sense of how to read the output sheet. Now let's actually see it employed within a research study. So go ahead and download this article. Here's the link to it. And stop the tape, and then come back and we'll have a debrief on the study. We are debriefing on the Wyatt study, which was entitled Satisfaction, Academic Rigor, and Interaction, Perceptions of Online Instruction. And in this, they used a one-way chi-square, which is looking at a single categorical variable. And there also is a two-way chi-square in which there's two categorical variables. So if we turn to page 462, we see their methodology, and you can see why they chose the chi-square as their technique. Because here they're using a questionnaire, and there are closed-ended questions and statements on the questionnaire. As I guess it looks like there's also a few open questions. But regardless, the question answer is one variable. But then they also test to see how those questions were answered when it came to gender and age, and that's two categories of variables. And so and notice too that all the categories are nominal. Again, they're using gender, they're using age, they're using just the answer to the questions. So you could see in question 1 where the answers are scheduling, distance, curious, like, home, and other. That is just nominal data. So that's why the chi-square is being used. You'll see that throughout their questions, whether you go to question 2 or question 3 or question 4, they're using nominal data to answer the questions, such as academically demanding is their category. And so throughout this study, you see the use of the chi-square. Now notice that they don't show you the statistical output sheet. That they would see themselves, but when they actually write the study, they just go ahead and write the results. So I'm now on page 465, and you can see under question 5, these results were not statistically significant, and they report their findings. So we see that it was greater than 0.05. So throughout the study, you'll see that they taken the results from their own statistical output sheet and actually just put it into the study. You don't really get to see the output sheet, but you understand now where these results come from because they've run some type of statistical analysis, and those were the results that they obtained. Okay, let's turn back to the workbook, and this time let's check out a second study. And this study is entitled Collaborative and Cooperative Approaches to Online Group Work. And I'm back on page 5 of our workbook. And so go ahead and pull up this study. Here's the link. And see how a chi-square is used in this study. And then shut this video off and then come back for a debrief. Okay, so now we're looking at the collaborative and cooperative approaches to online group work to see how this study employed a chi-square. And if you turn to page 116, you'll see that similar to the other study, they report the findings. Now, again, they acknowledge that they have, if you look at the bottom of page 116, they acknowledge the categories they're using. They really have two types of categories. So the first type is task type, and you have synthesis or application. And the second type of category is the type of move, which is conceptual or non-conceptual. And so you can see on the top of page 111, they create a table to give you an overview of how they're addressing those categories. But again, when it comes to addressing their findings, that you see that on page 118, again, they don't show you their statistical output sheet, but they do report on what that output sheet indicated. So if you look at 118 at the bottom of or underneath the table, it says the results of the chi-square revealed that task type was significant related to approach taken, and they report the results. So you could see though that the reason they used the chi-square for that particular analysis was because they were dealing with nominal data. So hopefully that gives you a better understanding of the chi-square. So let's now turn to page 6. And now we're going to focus on another statistical technique. This one's called ANOVA, which stands for Analysis of Variance. And a one-way ANOVA signifies a single independent variable, so one variable. And the fundamental purpose of using a one-way ANOVA is to see if there's any statistical significant differences amongst 3 or more test groups. Now remember, one variable, but multiple test groups. So for example, you may wish to compare samples of freshmen, seniors, and graduate students to see if they have any attitudinal differences toward participating in online classes. So the variable would be participation in online classes, but you got 3 different groups here: freshmen, seniors, grad students. You could have more. You could actually have freshmen, sophomores, seniors, or juniors. Let's not forget the juniors. So you could have multiple groups, but you have the one variable in a one-way ANOVA. Another example would be leadership effectiveness that was looked at to compare to high, medium, and low comprehensive groups. So again, we have an independent variable being leadership effectiveness, but we have 3 different types of groups. Now, in addition to the ANOVA, there's what's called the MANOVA, which is the multivariate analysis of variance. And to learn a little more about that, you can go to the site that's indicated here. If you want, go ahead and turn off the video, and you can go to that site to get a little more information. But you'll see that in a multivariate, it just means that you don't have a single independent variable. Instead, you have many independent variables. So let's get a better idea of what an ANOVA is. And this time, I want you to stop the tape, and I want you to view this video before proceeding. Now that you understand what an ANOVA is, let's review an SPSS output sheet that contains results from a one-way ANOVA. As you can see here, we have 3 different categories. We have 3 different groups. We have male, female, and other. And we have the category of salary. So these minimum and maximums and the mean are represented by salary, as you can see up here. Now, we get the descriptive statistics when we run the ANOVA, and then we get the actual ANOVA result. First, let's go through the descriptive statistics. So we see the mean score for males are about 79,500, females 53,900, and other 46,500. Now, one thing that you want to pay attention, and here's where the standard deviation is very informative. Notice that for the males, it's 52,635. That's telling you that there's quite a lot of variability between and amongst the scores as it relates to the mean score. In other words, there are some outlying scores that are influencing the mean of the males, particularly at the high end. We can see that the maximum here salary is $200,000, and that's kind of skewing the mean higher than perhaps if the subject who had $200,000 was eliminated. So we see the minimum and maximums of each. We see the mean and the standard deviation. But the big thing is when we run the statistics, just like with whether it be a t-test or a ANOVA or a chi-square or what have you, we want to find out, is it statistically significant? And we see here that 0.107 is greater than 0.05, so this analysis is not statistically significant. Let's now look at some actual studies, because you've conceptualized what an ANOVA is, you have a sense of how to read the output sheet. Now let's see how it's employed in a research study. So go ahead and pull out this research study, the link is here, and then come back for a debrief. Here we're looking at examining teacher verbal immediacy and sense of classroom community in online classes, and we're looking to see how an ANOVA was employed. And again, so I'm going to jump down to 489, and we can see that again, similar to the other test, when they show the results, even though they'll be looking at a statistical output sheet to gather their information, they don't include that in the study, they just include their findings. So we see the F test here and their findings. So if you look at something like that, if you just saw that without even reading what they wrote, is that statistically significant or not? And the answer is no, because 0.12 is greater than 0.05. So we see there's a result that's not statistically significant. Now in comparison, do we look at this, we see p less than 0.001, which is less than 0.05, and here they do have statistical significance. And then they're talking about a partial effect here and onward with different other results. So again, you can see how they're using the ANOVA. Here's a 2x2 ANOVA. And again, they will cite their results. They won't show their output sheets, but they make it pretty clear in terms of whether there were statistical significance or not. And you have all these F values which are indicating that. Now for now we're going to put this aside, but we're going to actually come back to this study because as you can see they used other analyses that we have gone over besides ANOVA, and so we're going to come back and talk about those in a little bit. But for now, to just give you a sense of trying to understand conceptually why they're using one analysis over another. And really it's because of the type of variables that they're using and the number of groups that are there. So again, with ANOVA, you're focused more on interval and ratio data rather than nominal data. Remember, nominal data is typically has to do with chi-square analyses. If you have ordinal data or interval data and only two groups, then you're more than likely going to do a t-test. Versus if you have multiple groups, then and you have interval and ratio data, then you're going to do more of an ANOVA analysis. So we're going to have one more section within this workshop which goes into a little more detail for that. But for now, just kind of start to sink in some of the concepts that have been explained to you. So let's go back to that study again, and I want to debrief on some of the other things going on in this study just for a review from what we have talked about in earlier lessons. So if you look here, table 1 is running some correlations, and we talked about correlations in an earlier module. So let's review some of these results to see if we can read the results as we learned in the past. So if you look here, this table 1 is running correlations, and here we're looking at, for example, in this box, the relationship between community and community. And I have to go back to the article to see how they're defining this community versus this. It looks like they're comparing the two, and it's showing that we have a correlation of 0.60 and it's statistically significant. So do you think this is a high, medium, or low correlation? It would be a medium correlation. Don't forget, correlations run on a scale from +1 to 0 to -1. And anything that's closer to 1 is high, anything that's closer to 0 is low. And remember that we have a positive and a negative. Positive means that the two variables go in the same direction. When you have a negative correlation such as this one, actually all of these are negative, but here, so if we look at this one, it's saying as learning goes up, community goes down, or as community goes up, learning goes down. So this negative correlation is statistically significant, but it's a rather low correlation. So that means there's some overlap between learning and community, but it's not a strong relationship, even though it's statistically significant. In contrast, if you look at here, satisfaction to satisfaction, this is a high correlation. 0.71 is closer to 1.0 rather than 0, and it is statistically significant. In contrast to that, if we look at this, we have posting to posting, and it's a negative, which means it's inverse, as one goes up, the other goes down, but 0.08 is extremely low. Oh, and notice it's not statistically significant, so it doesn't even really matter because there is no, it's a chance result rather than something that actually occurred. through the study. So let's try this again, because I believe there's more correlations here. Oh, we haven't really talked about regression analysis, and I don't want to get into too much of that because that's a little more advanced. But again, if you see a table like this, you're always looking for statistical significance to understand the results. So we can see here that in Model 1, when they use the default variable, the result is already statistically significant. It's under 0.05. But when they add the immediacy variable to see if it adds to the prediction, it is not statistically significant because it's greater than 0.05. And here what they're doing then is adding a third variable being community, and once again we see that it is statistically significant. So that actually adds to the prediction. Even if you know nothing else about the regression analysis, you can always go to the statistical significance box to see whether they produced, you know, statistically significant results or whether it was a chance happening. This is another regression model. Let me see if we have any more correlations. No. Okay, so we will end there. And we will go on to page 9. So you have a better understanding of ANOVA. We've had a few practices in interpreting the outputs. We've looked at some studies. And now we want to reinforce what is the best statistical tool to use when you are designing research studies. So the next video will help you determine what tool is best for the various purposes. So go ahead and stop the video and then watch this movie. If you turn to page 10 of the workbook, you'll see that we've come to the conclusion or the culmination of the 4 modules. You've completed all 4, and it's really time to combine all that you've learned and to apply it to actual studies. So this practice is going to allow you to test your knowledge and your skills. So the first thing you need to do in order to participate in this practice is to download this article, and here's the link. And then I want you to read the article, and then after doing so, I want you to answer these 8 questions. And after you get done answering the 8 questions, then I want you to come back to the video here, and we will have a video debrief. At this point, you should have read this study and answered the 8 questions on workbook page 10. And now we're going to go through our debrief. The first question asks, name 2 pieces of information within the study that communicates the demographic information of the subjects. So if you go to page 94, you can see that one of the demographics is gender, another one is age. And if you mention that they were communication studies, communication students, that too could qualify as an overall demographic description, but really the 2 categories look to be age and gender. Okay, number 2, what is the mean score for status? If you go to the next page, page 95, you see that there's some descriptive statistics of the scales in table 1, and if we look for status, we see the mean score is 2.76. Number 3 of our workbook says Table 1 on page 95 describes 5 scales. We see that kinship, lie, competition, status, and intimacy. Which scale has the highest standard deviation? So here's where it lists the standard deviations, and we see 1.18 is the highest, so competition has the highest standard deviation. Question 4. In Table 2, which scale produced the lowest mean and standard deviation? So here's Table 2. We look at the means. The lowest mean is male type, and the lowest standard deviation is from male type. Question 5. Table 3 shows various correlations. Describe in detail the relationship between competition and gender. So we see here competition and gender shows a negative 0.24, and we see these asterisks, which means it's statistically significant. It's actually statistically significant, if I can say it, at the 0.01 level, so it's even greater than this. So it's even a tighter statistical significance. And because it's negative, that means it's an inverse relationship. So as competition goes up, gender goes down. As gender goes up, competition goes down. And 0.24 indicates a low relationship because 0.24 is closer to 0 than it is to 1. Question 6. Look at table 3 again. This time describe in detail the relationship between competition and status. So competition and status is here. We got a 0.02 correlation. We notice it's not statistically significant. It's a positive. Had it been statistically significant, then it would have indicated as competition went up, status went up. As status went up, competition went up. But there's no statistical significance, and even if it did, this is extremely low because it's close to 0, so there'd be hardly any overlap between the two variables. Number 7, were the results of the one-way ANOVA statistically significant? For that, we have to turn to the next page, and you can actually see that they tell us that the one-way ANOVA findings were not statistically significant. And then finally, the regression analysis, again, even though this is a little more higher level, we did discuss whether you can tell whether something's statistically significant or not. And the question asked, review table 4 and determine if model 1 and model 2 are statistically significant. So if you look at model 1, you'll see that it's 0.647, which is greater than 0.05, so that's not statistically significant. And model 2 also is not statistically significant. So those are the answers to the practice, and hopefully you got all those correct. So that's pretty much it for this workshop and the workshop series on statistical concepts and tools. Throughout the 4 modules, you have enhanced your conceptual understanding of the various statistical techniques, and you also improved your skills in reading statistical output sheets, along with reading results stated within the research studies.